Check the voltage on the third stage. It's fluctuating too much.
I see it. Adjusting the bias now.
Bogey sighted bearing 090. All aircraft remain on standby.
Right here at grid reference 4. The last transmission was garbled.
I know. I'm trying to clear the frequency.
Got a faint return at bearing 290.
Roger that. Stabilizing the trace.
January 1940. The Atlantic night is absolute. Off the eastern seaboard of the United States, cold air presses low against the water. There are no searchlights sweeping the sky, no warning sirens, no screens glowing in darkened rooms. American coastlines stretch for thousands of miles, silent, unguarded, and blind. Far above the ocean, aircraft could pass unseen. Beneath the surface, submarines could move without challenge. In Europe, this kind of darkness has already proven deadly. Cities have burned because defenders did not know what was coming until it arrived. Fleets have vanished because warning came too late or not at all. Yet in Washington, in naval headquarters, and inside American factories, radar is not yet a weapon. It is an idea, a promise, an unfinished science. Across the Atlantic, Britain has learned a brutal lesson. Seeing first means surviving longer. The United States has not learned it yet, but time is running out. Within months, a quiet technological race will begin, not for bombs or ships, but for vision itself. And at the center of that race will stand an unlikely architect, a radio company named RCA, forced by war to teach a nation how to see the invisible. That urgency leads directly into the world that made radar necessary. By the time January 1940 arrived, the world had already learned that modern war moved faster than human senses could follow. In Europe, the sky was no longer empty space. It was a weapon corridor. Aircraft crossed borders in minutes. Bombers flew at night. Fighters emerged from clouds without warning. Traditional defenses, spotters with binoculars, acoustic listening devices, searchlights, belonged to another era. They were slow. They were imprecise. And against engines screaming at hundreds of miles per hour, they were nearly useless. Britain understood this before most nations because it had been forced to. During the late 1930s, as German rearmament accelerated, British intelligence recognized a simple truth. The next war would begin in the air. The question was not how to shoot bombers down, but how to know they were coming at all. Out of that fear came one of the most consequential technological systems of the 20th century. Along Britain's eastern and southern coasts, steel towers began rising quietly before the war. They looked ungainly, industrial, almost civilian, but stretched between them were antenna arrays connected to experimental transmitters. Together, they formed what became known as Chain Home, the world's first operational radar early warning network. Chain Home did not destroy aircraft. It did not fire a single shot. What it did instead was far more powerful. It gave Britain time. By transmitting radio waves into the sky and measuring their reflections from aircraft, British operators could detect incoming raids while German bombers were still over the North Sea. This meant fighters could be launched efficiently. Fuel could be conserved. Pilots could be directed precisely where they were needed. The air defense of Britain became a system, coordinated, layered, and anticipatory. Germany, for its part, was not blind to the value of detection. The Luftwaffe developed its own early warning radars, including the Freya and Würzburg systems. These were tactically effective, but never integrated into a nationwide defensive network with the same strategic clarity as Chain Home. German doctrine still leaned heavily on offense, on striking first rather than preparing to absorb blows. By September 1939, war erupted. Poland fell in weeks. By early 1940, the threat moved westward. And when France collapsed in June 1940, the Atlantic suddenly became the front line. The United States watched all of this from across the ocean. Officially neutral, America was not yet at war. But neutrality did not mean safety. German submarines ranged farther into the Atlantic each month. Long-range aircraft extended their patrols. The idea that oceans alone could protect the nation was beginning to erode. Yet technologically, the United States lagged behind. In 1940, America did not possess an operational, integrated radar defense system. Research existed. Experiments had been conducted. The U.S. Navy had dabbled with radio detection concepts in the early 1930s. Army Signal Corps laboratories had explored echo-ranging techniques. But these efforts were fragmented, underfunded, and slow. Radar was still treated as a scientific curiosity, not a strategic necessity. American military doctrine remained rooted in visual observation and patrol coverage. Coast watchers, aircraft scouts, ship lookouts, all depended on clear weather, daylight, and human perception. Against the pace of modern war, these methods were dangerously obsolete. This gap was not due to ignorance. It was due to urgency, or rather, the lack of it. The United States had not yet felt the pressure of existential threat. No cities had been bombed. No fleets destroyed within sight of home shores. Without that pressure, radar remained a solution waiting for a problem large enough to justify it. That problem arrived quietly in the summer of 1940. As Britain stood alone after France's defeat, Prime Minister Winston Churchill authorized one of the most extraordinary technology-sharing efforts in history. It would later be known as the Tizard Mission, named after Sir Henry Tizard, the British scientist tasked with carrying Britain's most sensitive military secrets across the Atlantic. In September 1940, a small British delegation arrived in the United States carrying a black metal box. Inside, it was a device that would fundamentally alter the trajectory of the war, the cavity magnetron. Unlike earlier radar transmitters, which were bulky, inefficient, and limited in resolution, the cavity magnetron could generate powerful microwave signals. This allowed radar systems to become smaller, more precise, and vastly more effective. Aircraft could be detected with greater accuracy. Submarines could be found. Fire control could be guided. The British, under siege and stretched thin, made a calculated decision. They could not mass-produce this technology alone. The United States could. What followed was a sudden, dramatic shift in American thinking. Radar was no longer theoretical. It was no longer optional. It was proven under fire. The U.S. Navy moved first. Concerned about fleet vulnerability, especially to air attack, naval planners accelerated radar development for shipboard use. Experimental sets such as CXAM and CXSAM were rushed into production. These early radars were crude by later standards, but they worked. They could detect aircraft beyond visual range. They could operate at night. They could see through cloud and darkness. At the same time, the Army recognized that air defense of the continental United States could not rely on fighters alone. Early warning was essential. Radar stations had to be built. Operators had to be trained. Doctrine had to change. This required industry. Enter Radio Corporation of America, RCA. Before the war, RCA was known for consumer radios, broadcasting equipment, and commercial electronics. It was not a weapons manufacturer, but it had something the military desperately needed: expertise in radio transmission, signal processing, and mass production. Under government contracts and intense pressure, RCA engineers began transforming laboratory concepts into deployable systems. Factories that once produced household radios now assembled radar transmitters and receivers. Civilian engineers learned military requirements and unforgiving pace. Alongside RCA, universities became weapons laboratories. At MIT, the radiation laboratory was established in late 1940, bringing together physicists, engineers, and mathematicians in a concentrated effort to master microwave radar. It became one of the largest scientific projects of the war. The shift was rapid, but not smooth. Components overheated. Signals drifted. Operators struggled to interpret unfamiliar displays. Every solution revealed another problem. And all the while, the strategic clock kept ticking. By the end of 1940, America was still officially at peace, but no longer naive. Radar sites were under construction. Ships sailed with experimental detection gear. Scientists worked through nights fueled by urgency rather than optimism. The nation was learning how to see without eyes. And as radar moved from theory into steel, wires, and glowing screens, its true test was approaching, one that would determine whether this new vision could survive the chaos of war itself. That question opens the door to the human, technical, and moral angles that shaped radar's rise. The rise of American radar was not a single story. It was many stories unfolding at the same time: human, technological, strategic, moral, each pushing against the others, each shaping what radar would become before the war even officially reached American shores. At the human level, radar was built by people who did not yet think of themselves as warriors. In RCA laboratories and factory floors, engineers arrived each morning wearing civilian clothes, carrying slide rules instead of sidearms. Many had spent the previous decade perfecting sound quality for radios or improving signal clarity for broadcast networks. Now they were asked to solve problems measured not in consumer satisfaction, but in lives lost or saved. These men and women worked under unfamiliar pressure. Specifications changed weekly. Military officers demanded results that physics sometimes resisted. A radar set that worked perfectly on paper failed in rain. A transmitter stable in a lab drifted wildly at sea. Every flaw carried consequence. Young engineers slept beside oscilloscopes. Older specialists relearned fundamentals at microwave frequencies no one had mass-produced before. There were no manuals. There was no precedent. Only urgency. At sea, naval officers faced a different kind of uncertainty. Radar challenged centuries of maritime tradition. Commanders trained to trust their eyes now had to trust a glowing screen interpreted by a junior operator. Blips appeared without context. False echoes mimicked aircraft. Weather interfered. At first, many captains treated radar as a supplement, not an authority. But those attitudes shifted quickly. When radar detected aircraft beyond visual range, it offered something no lookout could: time. Time to maneuver. Time to launch fighters. Time to prepare guns. Slowly, skepticism gave way to dependence. The technological angle revealed radar as both fragile and revolutionary. Early American radar sets were large, power-hungry, and temperamental. They required constant calibration. Vacuum tubes failed under vibration. Salt air corroded components. Heat buildup caused sudden shutdowns. Yet despite these flaws, radar did something no other system could do. It turned empty space into information. The cavity magnetron made this transformation possible. By enabling high-frequency microwave transmission, it allowed radar beams to narrow, improving resolution and accuracy. Targets could be distinguished from clutter. Range estimation improved. Fire control radars became feasible. This leap did not come easily. Engineers had to redesign waveguides, antennas, and receivers almost from scratch. Microwave theory moved from academic journals into factory blueprints in months. Leadership decisions shaped how quickly radar mattered. The U.S. Navy, with its culture of technical experimentation, embraced radar faster than the Army. Admirals authorized installations on battleships, cruisers, and aircraft carriers even before standardized doctrine existed. Training programs expanded. Radar officers were appointed. Entire watch systems were reorganized around electronic detection. The Army, responsible for homeland defense, faced a broader challenge. Radar stations had to be fixed in place. Networks had to be coordinated. Data had to be shared across command centers. This required not just equipment, but new organizational thinking. Radar forced militaries to become systems-based rather than platform-based. Detection, communication, interception all had to work together. This shift was cultural as much as technical. From the enemy's perspective, radar represented a dangerous asymmetry. German pilots over Britain had already experienced it. Raids intercepted with uncanny precision. Fighters appearing seemingly out of nowhere. Bombers tracked through cloud and darkness. Although German intelligence knew radar existed, it underestimated its integration and overestimated its vulnerability. For U-boats, radar threatened invisibility itself. Submarines relied on surfacing at night to recharge batteries. Radar-equipped aircraft turned darkness into exposure. Every ping risked detection. The Atlantic, once a sanctuary, became hostile space. This created a moral angle rarely discussed at the time. Radar stripped away surprise. It reduced ambiguity. It did not make war less violent, but it made it less blind. Defenders could act before destruction arrived. Civilian populations gained warning. Interceptors could be launched precisely rather than blindly. Yet radar also enabled more efficient killing. Targets identified earlier could be destroyed more reliably. Detection fed into fire control systems. The line between protection and lethality blurred. Industrially, radar transformed American production culture. RCA's conversion was emblematic of a broader shift. Consumer demand gave way to military priority. Production lines were retooled. Quality control tightened. Failure rates unacceptable in peacetime became intolerable in war. The company learned to work alongside the military, absorbing classified requirements and delivering under deadlines that ignored normal development cycles. This partnership laid the foundation for the American military-industrial complex that would dominate the post-war world. By late 1941, radar was no longer experimental. It was deployed, trusted, though not yet fully understood. It existed in the uneasy space between promise and proof. That proof would come not in laboratories or exercises, but in moments when warning arrived just in time, or failed by minutes. When screens glowed in darkened rooms while history approached unseen. Those moments would decide whether radar remained a hopeful innovation or became an indispensable weapon of modern war. They would arrive soon. The decisive test of American radar did not begin with a declaration of war. It began in quiet rooms, aboard moving ships, and along distant coastlines, where screens flickered, operators leaned forward, and invisible lines in the air suddenly mattered more than steel armor. By 1941, radar was no longer an experiment. It was installed, it was manned, and it was waiting on U.S. Navy vessels, the CXAM and CXAM. One radar sets had become operational. Mounted high on masts, their antennas rotated steadily, sending pulses of energy into the darkness. Below decks, in cramped compartments, sailors stared at cathode ray tubes glowing pale green. A sweep line moved in a slow, deliberate circle. When it passed over an echo, a bright mark appeared, something solid, somewhere beyond sight. At first, those marks were treated cautiously. Operators learned to distinguish between weather, sea clutter, and aircraft. They learned how altitude, speed, and bearing could be inferred from shape and movement. Every watch sharpened their instincts. Then the stakes rose. In the Pacific, long before December, American planners worried about surprise. Vast distances, limited bases, and vulnerable anchorages made early warning essential. Radar offered the possibility if it worked. On the morning of December 7th, 1941, at Opana Point on Oahu, two Army privates operating a mobile radar set detected a large formation approaching from the north. The blips were real, The range was long. The bearing was clear. The warning reached a duty officer unfamiliar with radar significance. The contact was dismissed as friendly aircraft. Radar had done its job. Humans had not. Pearl Harbor became a tragedy not of technological failure, but of institutional unreadiness. The lesson was brutal and immediate. Detection without understanding was meaningless. After Pearl Harbor, there was no debate left. Radar moved from auxiliary to essential overnight. Across both oceans, deployment accelerated. Training intensified. Doctrine hardened. Screens became authoritative. In the Atlantic, radar's turning point arrived with a fight against German U-boats. Early in the war, submarines had hunted with near impunity. Convoys were stalked at night. Escorts struggled to locate attackers once they submerged. Losses mounted. The Atlantic became a graveyard of tonnage. Radar changed that balance. Shipborne radar detected surface submarines beyond visual range, especially at night. Aircraft equipped with airborne radar could find U-boats attempting to recharge batteries under cover of darkness. The hunter became the hunted. Each detection was a moment of reversal. A blip, a course correction, a flare. Depth charges falling through black water. Statistics followed. Sinkings dropped. Convoy survival rates improved. The invisible threat lost its greatest advantage. In the air, radar reshaped defense. Ground-controlled interception allowed fighters to be vectored directly toward incoming aircraft. Instead of endless patrols, pilots were launched precisely when needed. Fuel was conserved. Coverage improved. The sky became organized space. Fire control radar transformed naval gunnery. Anti-aircraft batteries no longer relied on guesswork. Targets were tracked electronically. Shells found aircraft in cloud and darkness. Probability replaced chance. Radar success did not come without friction. Operators endured long hours of intense concentration. Fatigue caused errors. Equipment failed at critical moments. Weather still interfered. Jamming emerged as a new threat as enemies attempted to blind electronic eyes. But the trajectory was irreversible. By mid-1942, radar had become embedded in every major American operation. From carrier task forces to coastal defense networks, detection came first. Action followed. The war no longer began at visual range. It began at the edge of the electromagnetic horizon. One after another, battles quietly validated radar's worth. Not through spectacle, but through absence. Attacks intercepted. Ships not sunk. Cities warned in time. Radar rarely appeared in headlines. It did not have a face, but it changed outcomes invisibly. By the time American forces carried the fight deeper into the Pacific and across North Africa and Europe, radar was no longer remarkable. It was assumed. The decisive moment had passed, not in a single battle, but in the collective realization that blindness was no longer acceptable. War had learned to see, and with that vision secured, the consequences began to spread into strategy, industry, and the shape of conflict still to come. Once radar proved itself, it reshaped the war not through drama, but through permanence. By 1943, radar was no longer a specialized system reserved for elite units or experimental platforms. It was everywhere, on ships, on aircraft, along coastlines, inside command centers. The question was no longer whether to use radar, but how much could be integrated, refined, and expanded. The U.S. Navy standardized radar across its fleet. New ships were designed with radar in mind from the keel up. Masts grew taller. Power systems expanded. Combat information centers became the nerve centers of vessels, where radar, radio, and intelligence converged into a single operational picture. This integration changed how battles were fought. Carrier task forces operated with greater confidence beyond visual range. Radar picket ships extended the detection perimeter. Early warning allowed fighters to launch before enemy aircraft approached striking distance. Losses decreased. Efficiency increased. In the Atlantic, radar helped win a war of attrition. Convoy escort doctrine evolved around electronic detection. Radar and sonar worked together, surface and subsurface awareness merging into continuous coverage. U-boat commanders reported increasing difficulty operating undetected. Night, once their ally, became dangerous. German losses rose. Allied shipping losses fell. By mid-1943, the Battle of the Atlantic had turned decisively in the Allies' favor. Radar was not the only factor, but without it, the balance would have been far harder to achieve. On land, radar transformed air defense. The United States constructed a network of early warning stations along both coasts. Information flowed from radar sites to centralized command posts. Interceptor squadrons were launched based on electronic tracking rather than guesswork. Civil defense systems gained minutes of warning that could mean survival. This architecture of detection and response became a model replicated across theaters. In Europe, radar guided bombers to targets and fighters to interceptors. Navigation improved. Formation cohesion strengthened. Bad weather became less decisive. The numbers told the story quietly. More missions completed. Fewer aircraft lost. Higher interception rates. Radar's contribution appeared not as a single statistic, but as a pattern, a steady improvement in outcomes that once depended on chance. For industry, the aftermath was transformative. RCA and its counterparts emerged from the war fundamentally changed. What had begun as emergency conversion became long-term specialization. Radar manufacturing scaled massively. Quality control systems developed under wartime pressure became peacetime standards. The collaboration between government, military, and private industry deepened. Research laboratories expanded. Engineers moved fluidly between academia and defense. The template for large-scale technological mobilization was established. This relationship did not end with the war. Radar technology accelerated into new domains. Air traffic control, weather forecasting, navigation, astronomy. The ability to detect and interpret reflections became foundational to modern society. Strategically, radar altered military psychology. Surprise became harder to achieve. Stealth had to evolve. Camouflage shifted from visual to electronic. Countermeasures emerged. Jamming, deception, signal masking. Warfare expanded into the electromagnetic spectrum. The war taught militaries that seeing first often meant deciding first, and deciding first often meant winning. By 1945, radar was no longer discussed as a wartime innovation. It was an assumed capability, an invisible infrastructure supporting every operation. The transformation that began in 1940, when America had no radar equipment worth the name, ended with a nation that could detect threats across oceans and skies. The revolution had occurred without fanfare, and as peace returned, the implications reached far beyond military balance sheets or technological milestones. Radar had changed humanity's relationship with uncertainty itself. That realization leads to the final question, not of how radar worked, but of what it meant. Radar did not arrive on the battlefield with noise or spectacle. It did not announce itself with explosions or victory parades. It arrived quietly, measured in pulses, echoes, and glowing lines traced across dark screens. In 1940, the United States lived in a world where danger was still something you had to see to believe. Distance offered comfort. Night offered cover. Silence suggested safety. Radar dismantled those assumptions one by one. By teaching machines to perceive what human senses could not, the war crossed a threshold. Space was no longer empty. Darkness was no longer concealment. The future no longer approached unseen. The transformation was not just technological. It was psychological. Commanders learned to trust information they could not directly observe. Operators learned that a single mark on a screen could represent lives, fleets, cities. Decisions were made earlier, faster, and with consequences that unfolded miles away. Radar also revealed a deeper truth about modern warfare. Power increasingly belonged to those who could interpret information, not just deliver force. Seeing first reshaped strategy. Understanding first reshaped outcomes. The company that once sold radios to living rooms became part of a system that defended continents. Scientists who studied waves and frequencies found their work determining survival. The line between civilian innovation and military necessity blurred, leaving behind a permanent bond between science and security. When the war ended, radar remained. It guided aircraft safely home. It warned cities of storms. It tracked satellites crossing silent skies. The same technology born of fear became a tool of order. World War II is often remembered for its violence, its destruction, its scale. But beneath the noise, quieter revolutions unfolded. Revolutions that change how humanity understands space, time, and threat. Radar was one of them. It did not make war humane. It made it aware. And in that awareness, the modern world took shape, visible long before it arrived.